In this video for section M.1.10, we're going to translate phrases and sentences into expressions, equations, and inequalities. We've already done some of the translating phrases and sentences into expressions and equations back in section 1.5. So you can go back and look at those handouts and the notes that you took in class as we walk through that section. First thing we're going to do is we're going to remember the objectives, to pay attention to those. We got to define expressions, define equations, define inequalities. Just remember, inequality is the same thing as an equation, except instead of having an equal sign, you have an inequality symbol. We're going to show you those in a few moments on a table. Then we're going to have to write variables for unknowns and determine the necessary operations from contextual clues in a phrase or sentence. We also want to pay attention to our keywords down below. An equation is a mathematical statement that indicates the equality of two expressions. An expression is a finite string of mathematical symbols, including numbers, operations, variables that are grouped to show a value. An inequality is a mathematical statement with two expressions that do not have the same value. Again, they're going to have one of the inequality symbols. And to simplify means reducing a fraction or an expression to a simpler form by actions such as cancellation of common factors and regrouping of terms with the same variable. It's basically the same thing as solving an equation, except you're going to be solving an inequality. So we're going to go back to the top of the page here. Now, to be successful at this particular section on the TEAS task, you will need to practice shifting between the concrete and the abstract. So translating written language into algebra reduces the information to its most basic level. Sentence fragments become expressions. Full sentences become equations or inequalities. And here are a few examples of each one. You can notice from the expressions there are no equality symbols, so there's no equal sign. Then in an equation, no matter how difficult it is or how simple it is, you have an equal sign. And your inequalities is basically the same thing as an equation, except it has an inequality symbol. And so what we want to do is we want to go back to one of our tables and look and make sure we understand all the inequality symbols. Now this is the same table as is posted in section M.1.5, except now we've added the inequality symbols to our table. This is the less than, this is the greater than, this is the less than or equal to, and this is the greater than or equal to. And you can see a few little phrases that mean each one of these. It's very important you pick the right inequality symbol when you're setting up these word problems, so be careful. We want to keep reading in this section here to make sure we understand everything. Expressions are made of numbers, variables, and operations. Again, they don't have equal signs. When two or more expressions are combined with a symbol of equality or inequality, the algebra sentence is complete and you have either an equation or an inequality. These are both inequality statements. Now we need to look at an example of setting up either an equation or an inequality. But before we do that, let's go back to section 1.5 and review the two handouts that were in that section. The keywords and phrases for equations and inequality was a table I just showed you. We now want to go back and look at the general strategy for problem solving. Whether you're going to be doing an equation or an inequality, you have to follow these same rules. Now, no one word problem or no one word problem is going to be set up the same way as every other word problem. So what you have to do is you have to understand the problem. These are a few things that you can do to understand the problem. A couple of the key things you need to do when you're understanding is read the problem at least twice so that you don't miss any little particular word that may mean something very important. Then decide what they're asking for in the problem. Choose a variable and write down what it represents or what it means in the context of the problem. Then you may need other expressions using the same variable. Second step is translate the problem into an equation or inequality. You got to write an equation to solve the word problem. This is the most important thing to do because if you get your equation or inequality wrong, it doesn't matter if you solve it correctly, your answer is not going to be right. So once you have it translated into mathematical operations, numbers, and variables, you're going to come down here and you're going to solve the equation. This is usually the easiest step because if you got step 2 correct, solving it is not going to be that difficult, or hopefully won't not be that difficult. Then in step 4, this is the catch-all. If you've got step 2 correctly, then your answer is going to sound reasonable, but always make sure you add the units of measure. If step 2 is wrong, The only way you're going to know it's wrong is when you get down here and check your answer. Does it sound reasonable, or does it seem reasonable for the context of the problem? If it doesn't seem reasonable, then more than likely there's been a mistake in the translation. So you need to go back and redo the problem again. Now let's read this little word problem here that they've got in your book. It says Tony goes to a baseball game. During the 7th inning, he buys 4 hot dogs for $26 for himself and 3 friends. When he gets back to his seat, his friend Sally wants to know how much 1 hot dog costs. So what we're trying to do is we're trying to find out if 4 of them cost $26, how much is 1 of them going to cost? Well, hopefully you could do that one just without any extra help, but we're going to go through the steps on the problem solving. We're going to understand the problem. We're going to pick a variable and tell what it represents. He just let H equal the price of 1 hot dog. Then we're going to translate it. Well, we know there was 4 hot dogs, so 4 times H, it's got to equal $26. So we're all the way down to translation. Now all we have to do is solve it. To solve this equation, we know it's an equation because it was equal to, we're going to take 26 divided by 4 equals 6.5. So that when we check our answer, it says Tony knows that 1 hot dog is going to cost $6.50. Now, does that sound reasonable? At a ballpark, that probably is a reasonable answer. And the way that you would check it is, if 1 costs $6.50, multiply that price by 4 and see if it gets you $26, which you will. Now, this problem is a little bit more complicated, but still we're going to follow our same 4 steps. How many dollars do I get for my allowance? Asked a young boy. Well, if I gave you $12 more than 3 times your current allowance, you'd still have less than $19, says his dad. So we're going to look at some keywords here. D is equal to the son's allowance in dollars. That's how we're going to understand it. 3 times the son's allowance should be 3D. It's 3 times the allowance. So that gives us some information already from up here. If I gave you $12 more, that means plus 12. It's $12 more than 3 times the allowance. So this is one of our expressions. 3D plus 12. Now finally, make the total less than 19. Now it's got to be less than 19 tells me this has got to be an inequality with the less than symbol. So 3D plus 12 is less than 19. Now I'm going to let you finish it up and work it out. And you should get something that's approximately $2.33 as the kid's allowance. But check to make sure that my math's correct. And also go down here and work these practice problems. These practice problems I've worked out and posted in Canvas so you can get the answers and see how I worked each one of them out. And one thing you want to do is when you're working with inequality symbols is do you need to include the equal sign as part of the inequality? And these are a few examples showing you when and when not to include the equal sign. At least 5. That means it's got to be 5, 6, 7, etc. on and up. Can it be 5? Yes. It says at least 5 means 5 or more. So whatever we got to do is got to be greater than or equal to 5. In this example, it says more than 5. Well, can it be 5? No, not the way it's worded. It's got to be more than 5, so it's got to be greater than 5 and not have the equal sign here. On this particular example, it says no more than 5. Well, could it be 5? Yes. Could it be less than 5? Yes. So it could be anything 1, 2, 3, 4, or 5. So our answer's got to be less than or equal to 5. I can include 5 in this particular example. But in this one, it says less than 5. Well, I cannot include 5 as part of my answer. I can have 1, 2, 3, and 4, so my answer must be less than 5. And again, the more practice you have of whether or not you need to include the equal sign or not include the equal sign, just look at the little keywords on that previous table that I showed you at the beginning of the video. And it's also posted in your Canvas so that you can make sure that you understand it. Now let's work one last word problem example. I'm not going to tell you whether it's an equality or an inequality, and not going to tell you how to do it. But hopefully as you see my solution here, you're going to be able to understand it. This is on the last 3 math exams, the student scored 90, 89, and 82. What score must the student earn on the next exam, or the 4th exam, to have an average above 90? So there's a few things we got to know. We've already got 3 scores, and we're going to have a 4th one. That's the next exam. So I'm actually going to, when I find the average, I got to add all 3 of these numbers together, plus the 4th one, and then divide by 4 to find an average. Now we want it to be above 90. The question will be, as far as our inequality symbols, like up here is, can our average be 90? Or does it have to be more? Well, since it says above, that means it's got to be greater than 90. It can't be equal to, because above means greater than. So let's look at our solution. I'm just going to let X be the score that students makes on the next exam. So to find the average, we add the 3 exams we got, plus the 4th exam, which is unknown, together, then divide by the number of exams, 4, to get the student's final average. So you can see here, I took the 3 that I was given, plus the 4th one, which is unknown at this time, and I'm going to divide by 4. So I'm going to add the 3 that I got together, in other words, combine like terms, or add all 3 of these constants, and I'm going to get this part. This is part of an expression. Now, like I said, the final average must be above 90. This means the average must be greater than 90, so our inequality will be greater than. It can't be greater than or equal to, or that would be exactly 90. So we're going to have a greater than. And so we can see down here now, this is my whole inequality. What we need to do is we need to multiply both sides by 4 to clear out the fractions. We're going to get this. So multiply everything on this side by 4. That means the denominator goes away, and I just have 261 plus x on top. That's got to be greater than. Well, 4 times 90 is 360. Now I'm going to subtract 261 from both sides to get x by itself. I'm solving it just like it's an equation, even though it's an inequality. This is going to give us x has got to be greater than or equal to 99. So our student has to make a score of 99 or greater to have an average final above 90 after he completes his 4th exam. So hopefully this is kind of helping you work through these word problems and discuss what are the steps, appropriate steps to solve any word problem, whether it's an equation or an inequality.